We humans, with our space machines and giant telescopes, have been searching this vast universe for signs of alien life. And so far, we have found none. With its massive oceans and mighty mountain ranges, great rivers and green forests, dry deserts and diverse life forms, our wonderful Earth is the only planet that is known to hold life as of today. But in the 4.5 billion year long history of our planet, there have been not one, not two, but 5 major extinction events that wiped out up to 90% of total life on it and brought it dangerously close to a dead and lifeless planet. And yet, every single time, life somehow found a way and brought us to where we are today. And I am here to tell you these 5 remarkable stories of the time when life almost ceased to exist. Welcome to the Curious Octopus. Let's dive in. The story of each of these 5 major extinction events, periods on timeline of Earth when a large fraction of life disappears in a geologically short time, is nothing short of extraordinary. But we're talking about something that happened on Earth in a span of hundreds of millions of years. Over such long periods, continents form and break up, climate and temperature takes wild swings, life forms undergo major evolutions or may go extinct. So, for each of these stories, I'll first briefly set the stage as to how the conditions on Earth were at that particular time, and then describe how everything began to fall apart. On to the first story. This first story happened 444 million years ago. Oxygen in the atmosphere was lower than today, and temperatures were much warmer. Earth was a water world with continents that looked nothing like today. There were no permanent ice sheets anywhere on Earth, a greenhouse world. Instead, all the water was in massive oceans which covered most of the Earth's surface and in vast shallow seas that covered most of the lands. And these shallow seas were the cradle of early life, ancient life very different from today's. On the ocean floors covered with algae and corals lay primitive clams with their shells open. Trilobites crawled on these floors, scavenging for food. Ancestors of modern fish that looked more like eels with no jaws were swimming in these waters. And above them, 6 feet orthoceras with their tentacles were propelling through these depths, hunting their prey. Land, on the other hand, was almost desolate. No land animals existed, but first life had just moved to land from oceans. Early land plants that looked like liverworts that spread over tidal and moist lands. But something was already happening near the South Pole that would soon change the planet dramatically. One of the huge continent-sized land masses, called Gondwana, began to trigger this first major extinction. As plate tectonics pushed Gondwana over the South Pole, because land supports ice formation better than water, massive ice sheets formed on the southern land, locking the water. But this water came from shallow seas, which were the primary habitat of life. This stressed out the shallow water ecosystems of Earth. Moreover, this ice reflected sunlight and accelerated further freezing in a loop. Global temperatures plunged, but Earth's conditions could not sustain this ice age for long. Therefore, equally abrupt deglaciation occurred, soon flooding continents again. The influx of melted low-density freshwater from the ice formed a layer over the saline high-density ocean water and shut down vertical mixing. Oxygen therefore could not reach deeper waters. Marine life suffocated due to anoxia, lack of oxygen. This two-phase disaster, sudden cooling followed by warm suffocation, eliminated nearly 85% of marine species and came to be known as the Ordovician Silurian mass extinction. However, some marine life that could stand the sudden cooling and used to such low oxygen levels managed to hold on to life. and through them, life on Earth moved forward. This second story happened about 70 million years after the Ordovician Silurian mass extinction. Gondwana and all other land masses were still drifting, but slowly moving towards each other. Oxygen levels had improved. Temperatures were still warmer than today, but were on a downward trend. First terrestrial animals, the arthropods, like the millipedes, had just begun to colonize land. Marine diversity, on the other hand, was at its peak. While large armored fish swam in deeper oceans hunting smaller fish, vast coral reef systems thrived in the coastal waters and housed fishes very similar to modern fishes. The fins of some of these shallow water fishes evolved into limb-like structures, giving rise to the early tetrapods, animals with 4 limbs and a neck. But water was still essential for these animals to survive. So, these early tetrapods were living in the coastal waters but were testing out land. Plant life was transforming the planet. Simple ground-hugging plants were now joined by bigger plants and large trees. The 25-meter-tall Archaeopteryx. For the first time, true forests began to appear. The roots of these huge forests held the soil together, and first permanent river networks appeared on Earth, turning it lush and green. However, this biological revolution carried a hidden cost. These new expanding forests began to pull large amounts of carbon dioxide from the atmosphere for their photosynthesis, causing a decline in temperature. This sudden cooling stressed ecosystems. More importantly, these forests evolved deep root systems that cracked the bedrock containing minerals which had phosphorus, iron, and other nutrients. This nutrient-rich soil was carried into the oceans and seas by the newly formed rivers, causing explosive algal blooms in the oceans. When this algae died, sank, and began to decompose, it consumed oxygen in deeper waters rapidly. Ocean circulation could not replenish it fast enough, turning entire seafloors anoxic. Shallow reef systems collapsed first and then fish populations. This sudden cooling, followed by ocean anoxia, resulted in the late Devonian extinction that killed nearly 70% of Earth's species. Few life forms that were used to burrowing underground or adapted to living on low oxygen levels survived. Land plants made it through. And once again, life endured. Remember during the previous extinction when I said smaller land masses were slowly drifting towards one another? Over 100 million years later, those continents, along with Gondwana, finally merged to form the supercontinent Pangaea. Temperatures were warmer than today. Thanks to the huge forests covering the Earth, oxygen levels, though slightly lower than modern values, were now high enough to support large animals on land. From the tetrapods evolved the amphibians, animals that could live on both land and water but need water for reproduction, and amniotes, which are truly independent of water. Early sharks with strange whirly lower jaws swam in the oceans. Life on Earth, both land and water, was diverse and tightly interconnected. Then, the planet itself turned hostile. In what would become the largest volcanic event in Earth's history, the crust beneath present-day Siberia split open. Lasting for over hundreds of thousands of years, colossal fissures erupted, releasing lava. This was the Siberian Traps eruption. But lava was not the real killer. These eruptions released vast amounts of carbon dioxide and methane into the atmosphere. These gases trapped Earth's heat and global temperature surged by almost 10 degrees Celsius. Acid rain killed vegetation and wildfires raged across continents for days on end. In the oceans, warming caused circulation to collapse, cutting out oxygen from deeper waters, turning seas and oceans anoxic. Food webs collapsed and entire ecosystems that could not keep up with these quick changes died out. The result was the most severe biological crisis Earth has ever known. Life on land and in water took a major hit. Nearly 90% of total life vanished, resulting in the Permian Triassic mass extinction, or the Great Dying. Yet, even through this, life made it out. Small resilient survivors and reptiles that are used to living in such harsh and dry conditions made it through. From the ashes of near total destruction, Earth began its slowest and hardest recovery in its history. Around 50 million years after the Great Dying, Earth was about to face another crisis. The supercontinent Pangaea still stood largely intact, but its immense size came with a cost. Vast continental interiors that lay far from the oceans and their moisture turned into hot, arid deserts, while conifer forests lay closer to the coasts. From the amniotes came the mammals, which remained small, but reptiles which had survived the Great Dying thrived and dominated the land. Large reptiles that looked like huge crocodiles walked the earth, and through these reptiles, the very first dinosaurs evolved. 8-meter-long ichthyosaurs swam in the oceans. Then, deep beneath Pangaea, the planet began to tear itself apart. Heat rising from the Earth's mantle stretched the crust, opening massive rift systems hundreds of kilometers long. As the crust fractured, enormous volumes of magma surged upwards. This unleashed the Central Atlantic Magmatic Province, CAMP, one of the largest volcanic events in Earth's history. Over a relatively short geological time, vast lava flows erupted across what is now North America, South America, Africa, and Europe. Large amounts of carbon dioxide went into the atmosphere, rapidly heating up the planet, while sulfur dioxide caused acid rain, damaging vegetation. Wildfires raged across this rift, spreading outwards. Very soon, the volcanic eruptions, wildfires, and acid rains destabilized climates and collapsed food chains and ecosystems on land and oceans. This was the Triassic-Jurassic extinction that wiped out 80% of species. But from this destruction emerged a turning point in Earth's history. With their competitors gone, dinosaurs rose to dominance, and thus began the age of dinosaurs. 66 million years ago, that is 135 million years after the Triassic-Jurassic extinction, the Pangaea that broke up into two landmasses during the previous extinction even broke up further. Africa was now an isolated continent moving away from South America, opening up the Atlantic Ocean, while South America was itself moving towards North America. Antarctica was still connected to Australia, while India had broken up from this group and was on a collision course towards Asia. Earth had begun to resemble today's Earth. Oxygen levels broadly similar to modern values, warmer global temperatures, and higher carbon dioxide levels. Dinosaurs, large and small, ruled the land and air. T-Rexes walked through plains hunting, while Triceratops grazed on the plants alongside the rivers. Titanosaurs with their long necks reached for branches on tall trees and drank from large rivers. Birds, or rather avian dinosaurs, flew in the skies, while early bees and butterflies flew around the newly emerging flowering plants. Both terrestrial and marine ecosystems flourished with a variety of life forms. However, mammals still remained small, and most lived in tiny burrows in the ground. All was going well for life on Earth, until it didn't. This extinction came in two blows. First, the Deccan Traps. Massive fissures tens to hundreds of kilometers long in west-central India erupted. Red-hot lava poured out of these long cracks. Massive amounts of gases like carbon dioxide and sulfur dioxide escaped into the atmosphere from these fissures. While carbon dioxide rapidly heated up the planet, sulfur dioxide caused acid rain, damaging vegetation and turning oceans acidic. Then came the second blow, the killer. An asteroid 10 kilometers in diameter slammed into Earth in what is now Mexico and the Gulf of Mexico. This impact was in the order of 1 billion nuclear explosions. Initial air blast and the massive fireball caused an impact killed every life form in 500-kilometer radius instantly. Mega tsunamis hundreds of meters high devastated coastlines. Rock and debris shot into the upper atmosphere, if not beyond. As this fell back to Earth, friction with the atmosphere heated the rocks and it literally rained fire, causing more wildfires. Resulting ash blocked out the sun, shutting down photosynthesis. Food chains starved. First plants, then herbivores, and finally the predators that depended on these herbivores. The result was the Cretaceous Paleogene mass extinction, killing 75% of all species, ending the age of dinosaurs. Yet, all life was not lost. Remember the small mouse-like mammals that burrowed underground? Generations of these animals survived and waited out the calamity, which took thousands of years. When the skies finally cleared, the survivors inherited a transformed world and would eventually, millions of years later, evolve into us, humans. In the vast darkness of space, filled with billions of nuclear-powered stars that generate immense heat, and trillions of planets and planetesimals that move at alarming speeds, is a little rock that has a sea of magma on it. And floating on that magma is a thin layer of crust. And we humans share that crust with 1 million other species and call it our home. So when you think about how precariously we are living our lives, it is no wonder how many times the universe decided to press the reset button. Sometimes with extreme cold, sometimes with extreme heat, and sometimes just chucking huge space rocks at us. And despite all this, or probably because of all this, you and me are still here. And that is an absolute miracle. Thank you for watching. Until next time, keep asking why.